it would have been good to have a little more time to condense this. So basically what you're going to see are my notes, fairly detailed notes, but we'll go through each of the major bullet points. What I have highlighted in red is trying to capture the discussion that we already had. And what we're asking for at this point is feedback if there's anything that we missed and did not cover today. So if you recall,
anything that you missed, which we did cover
anything
today.
that I missed, yes. Okay, so we started off in the morning with a brief presentation by Melanie looking at simplified source models for Palo Verde. She talked about how models were simplified from the SSC recommendations. This was done in order to simplify the models, but to capture the important trends in hazard. She talked a little bit about the path effects. We went into much more detail later on about that. After that, Bob Youngs presented the logic tree structure. He looked at different source types, or the source type component of the logic tree, discussed the reasoning behind our selection of GMP models for each site and case. We looked at distributed normal faults, the case for distributed normal faults at Palo Verde and distance strike slip faults at Palo Verde. Do I need to go through all these minor bullets?
Yusuf's saying it's
Yusuf.
NGA, not NGS in data set 1.
Yeah, there's going to,
There's a bunch of-
frantically
yeah.
typing, so
Okay.
there we go. Thank you. Okay, so then down arrow to the next one. Oh, maybe over here.
The basic issue on the logic tree structure that we needed to capture was a mixture versus log normal.
Calling on the call.
So is this intended to capture the,
This? Yeah, we're okay. This is intended to capture discussion, so
yes, okay. Then
Doug has written much more
Under
than-
Melanie's, I thought one of the
I have a
conclusions.
lot more information here than the skeletal outline.
So under Melanie's, I thought one of the comments was to normalize her tornado plots to
we need to break the tornado to
not
isolate.
using the 2008 model, which gives you sort of a biased.
that is the
we
next
were having a
talk.
hard time understanding those tornado
Yeah.
plots. I guess it was to sort of isolate the different things.
Isolate the
Yeah.
the branches better, right? Okay. Yep. Keep going. Next one.
Next slide. Well, let me, it's different than a Mac. There we go. So hazard feedback and sensitivity results from walling. We looked at median motion sensitivity, the mixture model for sigma, for fat tail distributions, sigma sensitivity. Here there was some discussion. Adrian was asking why is the mixture model not centered on 1 on the tornado plot? Is the fat tail required? And Norm commented that we need to try to isolate the different contributors to make more sense about this.
So I think we just have to update the tornado plot to isolate the individual branch.
The individual branch, isolate. A little too tall for the podium. Let's see here. Okay. And John was asking about what is the rationale for not using the published sigmas. And, well, we discussed a lot of this in the afternoon. So I think that that has been fleshed out. Is there anything additional that we need to add? We looked at tau epistemic uncertainty and VSS epistemic uncertainty. And let's see. Misspelled Melanie. There was a question about an outlier at hazard of 10 to the minus 6, median much less than
Right.
1. It was about 0.2,
2
I
or
believe.
0.3,
Yeah.
right? We need to check on that
Yeah.
one.
Okay, so. Four. Okay, so here. Where's the slider? There we go. So hazard feedback and sensitivity results continued. So epistemic uncertainty in VSS at 0.5 hertz. Ralph Archuleta pointed out the systematics in which the values get smaller from the upper median to the lower distributions. It's not seen at this longer period. Melanie agreed that this was unusual and that she still needs to look into what might be
You
going on.
need to speak into the microphone. though.
Yeah, so this was different than was observed at PGA. So at lower frequencies, longer periods, there was the systematics that were observed at PGA, in which the values get smaller from the upper median to the lower distributions, was not seen at longer periods. And so Melanie was going to look into that. Epistemic uncertainties in VSP due to path effects do not show much variation. And
Yeah, instead of variation, I would
You
just
know-
say it's not much effect on the hazard.
can I do something, Carola, about this so that I can get the side scrolling bar here?
I don't think.
Well, I need to get up to the top so I
Yes.
can actually
Yeah,
access it.
yeah, we can fix that.
Just move it away.
Yeah, that's fine.
Is that okay in the
Yeah.
back? I'm going to need some help later too, because some of the more copious notes, the font kept getting smaller and smaller. Okay. Thank you. Okay, so is there anything that I did not capture? Okay. So we're on 4, so now I can scoot. This is harder than it looks. Okay, there we go. So ground motion models for host Arizona sources. This was presented by Norm. He presented the reasons for considering or not considering GMPE models for the median. Discussion of the evaluation data sets, NGA West 2, magnitudes greater than 5, distance less than 70 kilometers, plus data sets from each developer. This was suggested by Youssef. And then also the European data sets for magnitudes greater than 5 and distance less than 70 kilometers. And then we went into a discussion of the logic tree structure, and there was a number of comments that were made.
I don't think you have to read them.
Yeah, I
It'll
don't-
take too long, but let's see if there's anything that's key that we want to get. So here's a mixture model comment from Tom, or that we really ought to be looking at a non-Gaussian, and we do have that, so.
Yeah, and we have a lot more discussion along these lines in the later
Okay.
presentations. I'm sorry?
I was saying maybe you need only the action items, the issues that you have to take care of in the near
Yeah,
future.
that's what we need to be highlighting, anything that we need to do,
Right.
like fix this or change that as
Right.
we're
Yeah.
going along. It's fine to leave what you have, but anything we add, it should be so-and-so do this, okay?
Okay.
All right.
So does anything need to be changed?
No.
All right. All right, so continuation, normal earthquakes in the GMPEs. ASB has many more normal events, but it was
So-
pointed out that there's only, one to a few recordings per event, so.
But let's jump to, so Brian said, demonstrate that the
RJB.
simplified model based on RJB mimics hanging wall effects adequately
Right.
of a ruptured. That's what we need to do.
Count, what was the?
We need to demonstrate that the RJB common model captures the hanging wall effects.
So there's a discussion about confidence intervals.
I think we can go on.
Okay, so continuing,
So why isn't there a strike slip? Okay, so we need to add a strike slip capabilities to the models for the Arizona host zone.
yeah, that's actually down a little bit lower, isn't it?
That's fine. Do you see it somewhere?
Yeah, it's one of the red.
Yeah, it's right there. We'll need to build a strike slip case. Yeah,
Okay, so that's there.
yeah. All right.
All right, mean event term was discussed. We had a very interesting discussion about that. Thought the results were quite interesting. And then we went into a discussion of the regionalization of the salmons map. An elliptical grid was shown. The questions that remain are, what should the shape of the regionalization be in this space? Where should it be centered? Argument was made that more weight could be given in the direction towards the European models for this specific case, less weight in the opposite direction. So we had a detailed discussion about that. Ralph Archuleta asked the question about how do we choose a GMPE which GMPE to use in a given region. One suggestion was that we could look at the range of parameters in the region. Norm proposed an alternative argument, which is that we could define the regions in terms of the effect on the hazard. So in other words, the question is that in the salmon space, the regions aren't equal area. I guess is the point that I was raising on that. So maybe there's a way that the discretization could be done in the context of the parameter range or maybe in terms of the hazard sensitivity. So I think those are things that we're going to look at.
I think that's fine. And then on the next one, I think we could just say, can we put some magnitude and distance markers, scaling markers on the plots like we did before?
Yeah, that's a
So-
good idea.
We had some points that say if we scale a model, we change its magnitude scaling, steepen it up or make it flatter. Where does it go? Just to give you road signs on the salmon's map. Yeah, right. Nico, there's no reason that's stopping you from doing that, right? So just, other than time. Do you still think those are valuable, or is there anything that's misleading about them? No. Okay. All right. Yeah, it shows you the direction of magnitude scaling, the direction of distance scaling, so it helps you as
Yeah.
a map to move around the salmon's world.
Yeah, I think that would be good to have on really all of the maps, just it'll help with interpretation. There was also a comment made about whether or not we should also project models that were not used. And I was thinking about that, and I think there could be some value to that, because you could see if the models, first of all, plot within the distribution of the 1,000 models, or probably in many cases they're going to plot outside of that, just because those models use different data sets and did not have functional forms to capture particular types of behavior. And that could be useful for the centering argument, in that you could kind of rule out areas of the salmon space that way.
I don't know if it's a center, we'd say that's our range argument, right? This stuff, there's going to be edges you can't go far.
So this is a range argument here, and then plotting GMPEs that were argued not to be relevant for a particular case, to be for a particular source class.
Okay.
Plotting GMPs that were argued to not.
Doug, we got 5 minutes to get through all this. So that's fine. That's all we need. We can figure it out from there.
All right.
Okay. Next slide.
All right, so approach to the median distant California events. The median path term for northern, transitional, and southern sources was discussed. There are a couple of specific, can you guys read that?
Not at all.
Okay, so how do I make this bigger? Zoom? Oh, right, I need that. There we go.
But before we even go through all this, because we don't have time, let's remember what were the things that we wanted to have done.
We need to use a larger data set to compute the event terms.
Let's just put that as one big bullet. And just say not just TA array, not just events recorded by TA array.
I think that's in here.
Okay,
Probably on
that's
the
fine.
second, yeah.
The other part is the, I guess,
We need to evaluate how we separate the data sets for computing the average path terms. We can.
yeah, just say the north and south separation.
All right.
Right.
Need to average?
Evaluate.
I'm a little hard of hearing, but just separate. Right.
I've been using the microphone. Yeah. Sorry. Let's jump to the next one, Doug. And
Oh, we're already in the afternoon.
yeah. We're down to a few minutes, so let's just go to the next one.
Okay, so logic tree structure and models for phi.
So we wanted to get why the increase in phi SP for southern zones. So even if you just put it anywhere, that's
Let's
fine.
put it anywhere.
And do we have can we find an explanation for the increase in phi SS for the larger VS30? then someone asked for the fee estimate. That was John? Or did you ask that? Yeah. Just standard deviation of the delta estimate. Just write it down. Just say standard deviation of delta estimate. And then let's jump to the tau. Any other distributions?
I have multiple, maybe up to 2 slides for some of them, so I think I captured, we'll have. it'll be
Okay,
repeated,
enough
you know,
there.
some of what we just talked about is here.
Looking what you got, the CP, yeah. So I think that what you had, the key there is we're probably going to have to reduce that coefficient of variation from what Linda's using now to something more similar to what Adrian's evaluation showed. You had something that said that there.
Yeah, right here.
Okay,
So,
right. Okay,
so what was your phrasing? Redo?
that's good enough. We know what that says. We just want to make sure we didn't miss something. If we get to heavy tails, the, what?
Your model does not, for one of the earthquakes is much higher than the attenuation for, yeah.
Yusef, yeah. Correct. He had it already, yes. It's okay, he has lots of details, so we'll find it in there.
Plus we have recordings,
Minor reduction,
transcripts.
There was that wide range of the phi SS comma S, which was all lumped together for all conditions. And I think there could be value in seeing if that separates according to site.
Oh, right here.
Do you have that in there?
Yeah, so value in,
just separate phi SS comma S by site class.
Yes.
if I have that, then we will
Yeah.
duplicate it.
Linda, was there any other key thing that you were supposed to do? Okay. You've got, okay.
We're good? Okay, so these were the topics that, regarding Sigma that Bob discussed. He demonstrated that within event residuals for ASK and CY of heavy tails also occur in phi. What is it that we said we wanted to do? What is it we said we wanted to do?
This needs to just, yeah, more periods, more models.
Okay.
Just complete, need to do more periods and GMPE residuals. We could break the, explain the mixture model by regions,
By
by regional
okay.
differences. Okay? Anything else that any of you have made a comment on, you think we haven't captured that's an important part? You'll have one more shot at this tomorrow. I'm going to clean this up and turn them back into action items for us to make sure that we've got everything and people know what they need to do when they leave. Okay?
Linda, again, after that, right? So my only comment for Linda was that yaw small magnitude is too low standard deviation.
Yeah,
Maybe she has to remove it.
right. On the last slide, number 13. There you go. Just say Zhao Tao model not applicable to small magnitudes. Right? Okay. Ken?
It was also very different at long periods for the larger magnitudes. Very different than all the other models.
It's very
Just
different.
something to, evaluate.
Right, we need to evaluate it, but we're thinking it really even doesn't, it shouldn't be used at small magnitudes because it doesn't have enough
yeah, that
data
too,
there,
but
right.
even at large magnitudes, the period dependence too was very different from.
Okay, so evaluate Zhao Tao at long periods, right? All right. We need to stop there. Thank you, Doug. Just save that and then we'll clean that up.